Hello, my dear learners. I welcome you all to Shubhada Education, Sirsi. Here is your physics mentor, Satish sir. Let me take some of the problems on physics from JEE Mains 2023. These are all not memory based questions. These are all the actual questions of JEE Mains 2023. I will definitely try to solve all the problems of all the shifts of JEE Mains 2023 for sure for you people. Let me take the first problem now. It says, from the photoelectric effect experiment, following observations are made. Identify which of these are correct. The first statement, the stopping potential depends only on the work function of the metal. Okay, so let me try to take you to the solution now. So according to the problem statement, the stopping potential depends only on the work function of that particular metal. So during our theory classes, we have studied that the Einstein's photoelectric equation, energy of the incident photon or incident radiation, that must be is equal to the work function pi naught plus kinetic energy. As the first statement is related to the stopping potential, we can replace kinetic energy per charge, that is equal to potential V naught. So it implies kinetic energy can be written as charge E into potential V naught, stopping potential V naught. So now the Einstein's photoelectric equation becomes H mu is equal to pi naught plus E into V naught. Now we can clearly notice that V naught, stopping potential, depends on work function, also with the what? Frequency of the incident radiation. That's why the first statement is incorrect, because it depends on work function, also depends on the what? Frequency, we can say. Let's look at the second statement. The saturation current increases with increase in the intensity of the incident light. So during our observations, the study of the observations of photoelectric effect, we have seen that current increases as the intensity of the incident light increases, correct? So that's the reason why second statement is absolutely correct. It is, so therefore statement B is correct, we can say. And if you look at the third statement C, the maximum kinetic energy of a photoelectron depends on the intensity of the incident light. So again we have to use Einstein's photoelectric equation. According to this, H mu is equal to work function pi naught plus kinetic energy. Therefore kinetic energy depends on work function, also with the what? Frequency, but not on the what? Intensity. It doesn't depend on the what? Intensity of the incident light. That's the reason why statement C is incorrect, we can say. And if we look at the last statement, that is photoelectric effect can be explained by using wave theory of light. In wave optics, we have studied that wave optics always fails to explain the concept of photoelectric effect, but it successfully explains polarization, interference, diffraction, refraction, reflection and all, but it fails to explain photoelectric effect. That's why we can say statement D is also incorrect. Only statement B is correct. So therefore we can go for option C, that says as B is the only statement which is correct for this problem. Let me take you to the next problem now. Okay, so here is a problem based on the wave optics and Brewster's law, we can say. Here they have given two statements, statement 1 and statement 2. The statement 1 says, if the Brewster's angle for the light propagating from air to glass is theta b, then the Brewster's angle for the light propagating from glass to air is pi by 2 minus pi b. Okay, let me check with the statement 1 now. let me take the solution for the same problem. So let's try to solve this problem. We'll see. Okay, so the first one is this is the interface of air and glass here, the glass medium. Now the ray of light is propagating from air to glass. Okay, so here the polarizing angle is how much? Theta b is given. Theta b is the polarizing angle. It is also called as Brewster's angle. Now according to the Brewster's law, refractive index of the glass with respect to air is equal to tan of polarizing angle, that is what? Theta b we have to take. So we know that mu ga can be written as mu g divided by mu a, that is equal to tangent of theta b we can take. As you know that mu a value is 1, therefore we can take mu g, that is equal to tan theta b. This is for the what? When a ray of light is propagating from air to glass. In the second condition, they have clearly given that when then the Brewster's angle for the light propagating from glass to air. Now it is a glass medium and this is the air medium. Okay, at that time you need to get the value for the what? Brewster's angle now. Okay, now the ray of light travels like this. Okay, propagating from the glass to air. In this case, refractive index of the air with respect to glass must be equal to tan theta b we can take. Okay, so therefore mu a divided by mu g, that is equal to tan theta b we can take, or what we can write now? Mu a is 1 by mu g, therefore we can write mu g equal to cot of theta b, because reciprocally we need to take. So now we have to replace cot in terms of the what? Tan theta. We know that cot of 90 minus theta is nothing but cot theta. So therefore we can write mu g is equal to tan of, mu g can be written as tan of 90 minus theta b, or else pi by 2 minus theta b. Now you can see theta b, and here we have 90 minus theta b, that is what? Pi by 2 minus theta b. Both are equivalent, therefore we can say that statement 1 is exactly correct. Okay, statement 1 is absolutely correct. And if you look at the second statement given there, okay, second statement, according to his Brewster's angle for the light propagating from glass to air is tan inverse of mu g is given. Now the ray of light is propagating from where to where? Glass to air. Okay, glass to air it is. Now we can write refractive index of the air with respect to glass equal to tan of theta b we can take. Therefore mu a by mu g, that is what? Mu a divided by mu g equal to tan of theta b, or else theta b must be equal to tan inverse of 1 by mu we can take. So but they have given tan inverse of mu g, that's the reason why statement 2 is incorrect. So only statement 1 is true and statement 2 is false, that is in option A. That's why we are going for option A as the right answer for this problem. Let's look at the third problem now. Okay, it says that a circular loop of radius r is carrying a current I ampere. The ratio of magnetic field at the center of the circular loop and at a distance r from the center of the loop on its axis is the question. Okay, so in each and every class I will definitely explain about the ratio of magnetic field at the center to the magnetic field on its axis must be equal to 1 plus x square divided by r square whole to the power of 3 by 2. Okay, so here x is the distance along the axis and r is the radius. So if you notice the problem statement, radius of the circular loop is r and you need to get the value for magnetic field along the axis distance of what? Same r. So now we can take x is equal to r, x is also equal to r, and radius is also equal to small r. So now let's substitute the values in this equation and let me try to get the answer for the same. Ratio magnetic field at the center to the axis must be equal to 1 plus r square divided by r square whole to the power of 3 by 2. That is equal to 1 plus 1 whole to the power of 3 by 2. That is equal to 2 to the power of 3 by 2 we can take. Now this can be written as 2 to the power of 3 whole to the power of 1 by 2. Therefore ratio magnetic field at the center to the magnetic field on the axis must be equal to 2 to the power of 3 is 8 root 8 whole to the power of 1 by 2 is nothing but 8. We can write 8 as 2 into 4, that is equal to 2 root 2 is to 1. So 2 root 2 is to 1 should be the right answer for this problem, that is in option. 2 root 2 is to 1, that is in option B. That is the right answer for this problem. Let's move to the next problem. In vector E and vector K represent electric field and propagation vectors of the electromagnetic waves in vacuum. Then the magnetic field vector is given by. This is a very good problem this year. So as we have seen that the speed of electromagnetic wave, okay, speed of electromagnetic wave, we can take it as a c, that is equal to, how we can write, E naught divided by B naught we can write. So this is the what magnitude of the electric field vector, B naught is the magnitude of the magnetic field vector we can take. So similarly we can write the propagation constant k is equal to omega divided by c, angular velocity omega as well as speed of light c. Okay, so because here the option consists of the what, omega as well as propagation constant or propagation vector, that's why we have to replace that. By using this one we can say c is equal to omega by k we can take. So therefore what we can write now, omega by equal to, therefore omega divided by k, that is equal to we can take E naught divided by B naught. The question is all about B naught, magnetic field component, equal to E naught into K divided by omega. So both are vectors, we can take it as in the vector quantity. Therefore its value is E naught cross K vector divided by omega. That is in option B, which is the right answer for this problem. Okay. I will definitely try to solve number of the questions from JEE Mains 2023 for sure. Keep on watching the video and get prepared well for examinations. Thank you very much.